Okay, welcome back. This is the second time we're going to talk about arrays and chapter 8, which is our last chapter. So last time we finished up with this slide where we're talking about auto numbering or auto assignment of data type. That is in version 11 of C++, and also the advanced for loop. So let's see, how would you even test this? How would you even learn about something like that? Okay. So you can have just a simple project created, right? So you can create a simple hello world. And we're going to return 0, right? What's wrong? Not string, right? Okay. So what happens if we're going to have, let's say, an auto value equals 15? Okay. So you can just type that in and stop the code, run your code, and see what happens. So if we just set 15, you can see that the type of the variable or the identifier value is an integer. So what happens if we're going to have an initial value of 15.0? When you run this code, you can see that now it is a double. Now what happens if we're going to have something like this? Then you can see that the system automatically identifies this identifier as a character, right? So the auto keyword, again, it's going to depend on your compiler, what version of C++ you're using, if it's going to be supported or not. But now this can be used. So it is a great way of automatically determine a value. But you can see if you want to do a float, right, and you're going to say float 15, this would be really hard to achieve with the auto keyword in C++, because 15 would be considered as integer. And if you want to force it to be a floating point value, by default it will take it as a double and not a float. So make sure that you understand that, right? That we have this keyword now that you can use, but that kind of takes away the strength of C++, where C++ supposedly a strongly typed programming language. Strongly typed means that we always have to define what is the data type of our variable, and this auto keyword takes that away from us because it kind of makes it loosely typed language. So be careful if you decide to use it. Now the other concept was the enhanced for loop, right? So now because we know about the arrays, so let's say I have an array, an integer type of an array, and let's call it my array of, let's say, 20 items. And let's just initialize it to 0. Okay. So now how do we process this array? Well, we can process this array by saying int I equals 0, right? And I is less than 20, where we increment I. And if we want to print out the value, then we need to look at each one of the values one at a time, where we're stepping through the index of the array. And that would work just fine. Okay? So how do we make this into the enhanced version of the for loop? Okay? We still need to have something to hold individual values, but this time is not going to be an index value. It's just going to be something that holds a value. And we don't use the semicolon, we use the colon, and we're going to send the actual array. Okay? So now we are not printing out the index value within my array, but we are printing out the values within each one of the elements inside the array. So here I is referring to the index value. My array at the subscript index value is the actual value. In the second example, I is actually the variable that holds the value at each individual index location, but we do not have to worry about indexing. So what happens if I change the size of my array to 5? Now we just made a mistake because our array is out of bound as we are processing this, right? Because we're going into index value 5, 6, 7, all the way to 19. But now we don't have that. Okay. Now what if we want to process this in the update? We're going to make a mistake and we're going to decrement. So we're going into a negative territory. We made a mistake again with our array processing. So we need to make sure that we are updating the loop control variable properly. All right. What would be the problem here? In this case, we start at the wrong place, right? So if my array has 20 elements and I start at 5, then I skipped the first 5 elements. Again, I made a mistake processing the whole array. So how do we eliminate that problem? Okay. Now I changed my array size to 5. I have problem in this processing, but this processing will not have any problems. Right? So if we comment this out, and let's say we have 5 elements in the array, we have the 5 elements printed out. If we increase that to 15 elements, we're never going to be out of bound, and we're never going to be processing the array the wrong way. Okay, so that's one of the benefits of using this type of array processing. Okay, so let's go back to the PowerPoint. Okay. So very simply, you can learn about how to use these different structures within C++ with just a simple, basic examples. Okay. So what is the C string about, and how does that work? Now, if you look at a string, okay, So let's say we have a string. What is a string? String looks like these different elements. And we have characters in each one of the locations. 0, 1, 2, 3, 4, and 5. So this is how we look at a string, right? And this is the string type. But when we look at it, the string needs to know, okay, how do we know that we need to stop after we printed the exclamation point? How does the string know where it needs to stop? Now, if we go too far within the string, right, then we're going to be out of bound. So we cannot have that. So when you're looking at the string itself, inside the string, okay, this is where we're going into object-oriented programming. Okay, when you have a string, and we have 0, 1, 2, 3, 4, okay, each one of these location for a character, right? So each one of these are just characters. So after we have the characters, we need to tell the system where to stop processing those characters. Now, beside that, it would be nice to ask this structure right here, which is a collection of characters, what is the length of this character string, character collection, okay? And what is the capacity of this, right? So really, when you look at it, right, we have a character array, and then we have properties of that character array. Now, when you look at it, okay, when you take all this together, now that becomes an object. So the object has values and it has properties. And this is what a string looks like, right? So the key thing is, when we have a character array inside a string, we have to null terminate it. So this is the terminating string, the terminating character that tells the system where the string ends. Do we know where it starts? Well, the starting point is the base pointer, right? So we learned about the base pointer is the same thing as the first element in the array. So we know where it starts, we just don't know where it ends. Because we don't know how long of a string we are going to store in our array, we need to look at it. So first, before we look or store something, we need to look at what is our current capacity. If the capacity holds the length of the string, then we write it into the array, and then we set the length that shows what is the length of my string at this point, right? So in this case, it's going to be 5, but the capacity might be 16. So we need to look at this as all of this information, the array and the properties, which is the size of it, the length of it, and the capacity of the actual current array, is what we call a string. And the string has to be null terminated. So when we are printing out, okay, when we are printing something, then we keep printing each character until we hit this, and then we must stop. Now, if we have a character array, okay, So it's not a string. It's just a character array. In the array, we need to know the size of the array. So within the size of the array, so in this case, what is the size of the array? 0, 1, 2, 3, 4, 5, 6, 7, 8. So that is going to be 9 characters, right? So we can have a character A, 9 elements, where the largest element is 8, because we start at 0. So now, when we're talking about a character array, we don't have this security, we don't have this structure that does everything for us. Okay, we have to handle the raw array elements individually. So now, when we have the characters that we want to fill in, and we want to say hello, then we have to manually put in the terminating character after we're done filling the array with characters. And that's what we call a C string. So C string always going to have a terminating null character at the end of it. Okay? So we need to count for that extra character. The terminating null character will take up a space. So if we have an array of 16 elements, that means we can actually only hold 15 characters, because the 16th character is going to be the non-terminating character. So if we store string that is less than the array size, the last component are not used. So if we are initializing the array elements at the declaration, during the declaration, then we can skip the size of the array, just like when we were talking about the numbers, right? So if we have individual elements, then we have, let's say, an integer array, right? And we initialize all the array elements at the same time, we do not have to specify the size, because it will create all the needed spaces, right? 1 character, 2 character, 3 character, 4 characters, and because it is a character array, we are going to create an array of size 5. So, because we don't have that surrounding object, what we call a string, okay, we need to have different methods. These different methods that work on character arrays or C strings. So why is it called a C string? Well, character string, because these are not just individual characters, but these characters represent a string. So it's not just A, B, C, where you want to store somebody's letter grades, right? So A, B, C, and D, those are individual characters. They can be stored in a character array. That's a character array. Now, if I store a string called student, now student also has individual characters, but student, each individual character referring to an actual string, and that's what we have right here. So John is a collection of characters, but those collection of characters are referring to a string, but the string is stored in a character array that we need to terminate with a null character. So it is going to be called a C string, not just a character array. Okay, so we need some functions that will that will work on character or C string specifically. Okay, so if we go back to that drawing right here, so that means we have a C string inside a string with other stuff inside of it. All right? So that means we should be able to extract just the C string. Okay, so we're gonna have a method, right? A method that we access by the dot operator, and we're gonna be able to get the C string out of a string. Okay, so let's see how that works. Okay, so here's a simple example. Okay, let's just comment this out for now. We don't really need any of that. Okay, so let's say we have strings. Okay, what are strings? Strings are structures, objects that have C strings inside them. So let's see what that looks like. Okay, so we can put in a breakpoint in our code. We run our code. Okay, so what we are interested in is looking at what a string looks like. Okay, so you can see here's a string. Okay, so we have the size of it, and we have its capacity. What's the size of it? 0 through 7, so we have 8 characters right now in this string, but we can take up to 15 characters with the capacity. So why is it 15? Why not 16? Well, because the 16th character is going to be the terminating character. So it only allows to have 15 because it is already taking away the last character. So what does that look like? Now in Visual Studio, it depends on your IDE. You can either do this in your IDE or not, but mainly you're going to see something in Visual Studio also allows you to look at the raw data within the string. So not this pretty formatted string, but we can look at the raw data, which is a little bit uglier. So let's look at it. We go into _bx. We're going into the buffer. Okay. Now this is what it really looks like. Okay. See how the size is 0 through 15. So how many characters we have? What is the capacity of this? Really, it is 16. But it's not really 16 because soon as we store a string inside, the last character will show where the string ends. So we have the terminating 0 or null character. Okay, so this is not 0, this is null character. Okay, so when we have the null character, it will tell you about where the string ends. But the capacity is larger, right? Just like the chapter said, we are not using anything in the array if the string that we assign to an array is shorter than the size of the array. So the size of the array is 16. We only stored 8 characters. The 9th character is the null character. So the rest of them is going to be garbage values, or just basically default values. Okay. So that's what it looks like. So you can see that this is the raw or the character array or the C string inside the string. Now what we can do, so if we stop this and you type in the name of your identifier and then type in the dot, you get the drop-down list. And in the drop-down list, you can see that we have many available functions that's available to us to use as a string, and one of the function is CSTR, right? So you can see that this is going to be an actual function that extracts the C string out of the string. And this is where you have the string compare method. The string compare method will compare two C strings. Okay? So how do we compare two C strings? One character at a time. So when you look at it, the one character at a time, okay, what you have is an array. So you can have an array. Let's say this is going to be called A, and then you have another array, and that's going to be B. So now, because each one of the arrays indexed, so you have 0, 1, 2. Now we can take one index value at a time and then compare each item at each index value one at a time to make a determination if one array is less than or greater than based on the ASCII code. Just like we were talking about when we had strings. Okay? So in this case, we are using a string compare that requires us to have a character array sent to it, or two character arrays. So now, instead of sending the string, we are sending the character arrays by extracting the C strings. Okay. Now in this case, okay, let me just show you. The book mentions string copy, right? So if we are using a string copy, okay, then we should be able to take the source and destination, okay, let's see. Let's see, why is it not taking the destination? Okay. So now look at the signature, right? So I'm looking at this gray area, right? You can see that in the parentheses, the source is a constant character. The asterisk means it's a pointer, okay? And the destination needs to be changed, so it doesn't need to be a constant. So I'm not sending a constant string array, but just a array that can be modified, because we need to overwrite it, right? So let's just take this one out so you guys can see what happens. Okay. So when we compile it, right, we get an error message, and the error message says that it was determined that just a string copy does everything the wrong way behind the scene, is not secure anymore. So we should, even though it's in the language, okay, this IDE, the Visual Basic. The Visual Studio does not allow you to create an application anymore with unsecure functions. So we need to get rid of that one. Okay? And what we do is we will use the secure version of it. So when we use the secure version of it, okay, it's going to be copying the string in a more secure fashion. And so basically, it's just a side note. Don't ever use just a regular string copy anymore. Okay, so behind the scene, right, we take the constant value, so we don't change it, and then we copy it into another string, and then we can just print on the resulting string. The string length. Why do we need the string length method or the string length function? Well, we need it because now we do not have the string object that keeps track of the size and the capacity of the array, right? Because now it's just a raw character array. So we still can figure out what is the size because we have the terminating character. So we can have a for loop, right, to calculate how many characters are in the array, and just by sending the character array to the method. And we don't have to implement it because here the actual function that's available to us is going to do the same thing. So the only thing it does is just a for loop counting the characters. But if we have just a string, right, if we don't look at the C string version of the string, but the whole object, now within the object we can just call a function, size and length and capacity. We have all that available to us. So the string gives you all the different methods to make your life easier, but the C string allows you to have a linear code, or a linear array representing a string, but then you have to use different methods, or you might have to implement your own methods and functions. Okay, but that's what they do. So if we look at it, when we run this code, now we're using the string copy secure version of it, right? So if you look at the output, okay, so you look at the output, then we have the string compare, okay? What comes out of it, okay, let me stop this from running, okay? See what is front of the actual function when you look at the function. Okay. So here's the name of the function, right? And then you have the first parameter, comma, second parameter. Okay, so we have the constant and a constant. So we don't want to change when we're comparing strings. So both of the constant character arrays were accepted by this function. So what comes out of this function? An integer comes out of it, right? So what does that mean when an integer comes out of it? Right? So it means 1. So what is 1? Well, I don't know. So why don't we try it? So right now we have Richland and then we have college, what we compared. So what if we compare Richland and Richland? What happens then? Now you can see that the result of a comparison is 0, right? So what if we change or add something to the first element? If the first element is In this case, it is longer, right? And then we have the number 2. Number 2 is before A, so when you're comparing it, this is where the discrepancy will come in, right? So 2 comes before in the ASCII code table than the lowercase a. So what we compare, the first one is less than the second one, so it comes first in the alphabet. Then we get a result of -1. If they are exactly the same, you get a 0 back. Okay, so it's not going to be a Boolean. Not that let's compare it. Are they the same? Yes or no? No, we have different stages, right? Less than, equal to, or greater than. Okay, so now let's put 2 over here. Okay, stop this one, run it, and now we get a +1 value. So what does that mean? It means string 1 is greater than string 2, okay? Because L has a higher ASCII value than 2 in the ASCII table. Okay? So you can play this kind of a game with your compiler, okay? And then you can see how these methods actually work. Okay, so let's move on. So now after we copy, right, we copy 2, which is space college. We are copying it to the array, character array, and then we're printing out the character array. What's in the character array? Character array now holds space college. If you look at the 2 array, you can see that we have the space, then we have college, and the copy operation actually placed the terminating /0 at the end of the array. Now, if you look at the rest of the characters, okay, it's interesting to note that it is not the same -52 what we usually get with the character garbage value. Okay, but that would be characters that you can test in your code. Okay, so anyway, so we have a character array that has a string copied into it now, 1 character at a time, and terminated with a null character. Okay. Then we look at the length of the string. Okay, length of the string. When we extract the C string out of it, you can see the size of it is A, which would be the same thing if we would leave it as a string, and if we would have called the size and the length function. Okay, they both of them the same values, or we could have called the capacity function, and it shows us the capacity. Okay, so this is how you would use that that particular function, right? But here we are using these functions that are specifically designed for C strings, while here we have functions that are used with strings. Okay, so another interesting concept. So let's just move into, let's get rid of this. Let's move into a little bit of array processing. Okay. Now in this case, okay, when you process an array, okay, let's say here array element 0 is set to Richland, array element 1 is set to college. Okay. But A is a one-dimensional array of a string type. Now really when you look at it, what is a one-dimensional array of string type? What is an array? An array is something like that, right? And then we have 0, 1, and the third element at index value 2. Now what happens when this is not an integer, right? So integer would be like 15, 20, and 30, right? But this is an array of a string. Now what happens? An array of string is really a two-dimensional character array, because array element really holds elements of a character array. I'm just going to stop right there, but you can see that when you look at the index values, right, it is a string, so we only look at the index value that gets us to that array element. But when you look at a string, the string has its internal structure, which is a character array. So in this case, when you're looking at referring to the array, even though it is a string type, you can process that array as a two-dimensional character array. So you can see in this case, okay, this is a nested for loop. So first of all, you have W, and within W, you have the nested loop where you're going to have the value of Y. Okay? And we're going to print out the W and Y. We're going to print out the W and Y values. Okay. Oh, I put it in the wrong place. Okay. W and Y. Okay. So we are looping around here. Okay. This never happens. Okay. The inner loop goes into the outer loop, and then eventually we're gonna step with that. Okay. So what happens here? This is W. W will have a value of 0, and then Y gonna have a 0. What is it that we're gonna print out? We're gonna print out 0, 0 location. Okay. And then we update only the Y value because we are still in the inner loop. At that point, 0 changes to 1. Now what we're going to print out? We're printing out 0 and element 1, which is I. At that one point, we again update Y. When we're updating Y, I becomes 2. Right? Then W is still 0, and now we are printing out element index 2, which is element C. So we go through all that, and then when we go to the outer loop, then we update W to 1. So now when we're printing it out, we reset Y to 0. So now it's 1, 0. So here we're going to have space, no space. Okay. So we have C, O, L, L, E, and the keep continues on. Okay. But now what we're printing out is 1, 0, which is C, and then we increment the Y, 1, 2, which is 1, 1. So then we have O, we increment the Y, there's going to be 1, 2, L. Then we increment the Y to 3, so there's going to be 1, 3 coordinate, and there's going to be L. and we move all the way until we process the whole array. Right, so that's what it's doing right here in this example. And when you print the first row, before you update the outer loop, here I'm just printing out an extra space to separate the two words. Okay? So in this case, we are controlling exactly how we're printing out the array. Now in this particular case, when we have an array B, it's a character array which has 4 rows and 5 columns. And that's going to be interesting to see what happens there. So let's just go through and see how this works right here. So let's go through the inner loop. And let's go through the inner loop right here. So you can see each iteration. Okay. And right before we print something out. Okay, let's see how that works. Okay, so we have nothing in the output. We continue on. So y is 0, w is 0. Now we have y is 1 and w is 0. Okay, so when y and w was 0, we printed out r. R was the first element in our first row. So now we have y1, but because we are in the inner loop, right, we are within this inner loop, then we only increment y. Okay. So first row, second element is going to be I. So one element at a time, it prints out each individual characters, even though A is a string array. Okay, you can see how the incrementing y, but right now we are at w1. So that is the second row what we are printing out. Okay, so in this case, let's see, I want to print out hello me. Okay, so what happens in that case? Now we are in array B. In array B, you can see that here is the first row. Remember, we have 4 rows and 5 columns in each one of the rows. Now, what does that look like? If you look at the details of this array, you can see how reading into the array, how do we read into the array? We are reading into an array by using the get method, and we're forcing the get method to read 5 characters. Okay, so as we are reading the 5 characters, the 5 characters includes the terminating value. Okay, so you're really reading 4 characters, and then the 5th character is the terminating value. Okay, so it's going to be hello, let's say hello you. Let's see what happens. Now we have the second row. You can see that if the second row reading 5 values, we really need reading 4, because the get method will reserve the last character to be the proper terminating character, which is the /0. You don't ask the user to enter that in. Alright? So then we continue on, and we say hello us. Okay? Now we have the third row field, so we have the third row field, then we continue and say hello. Okay, so now we have index 3, which is the fourth row, also field. So when we print out the results, it just say hell. Alright? It's an unexpected outcome. You would not have this problem if we would read it into a string. But C strings work differently. Okay? So what if we use a different way of reading into an array, character array? Right? So what will happen if we would just say read into individual rows? So if we just use CIN, and here we're just going to say row 0, fill row 0, row 1, row 2, and row 3. Okay? So we don't need this anymore. Hopefully you guys understand that we are processing a string array, one character at a time, as a two-dimensional array. So let's look at this. And again, I'm going to type in hello me. Okay. So we are in array B. So you can see here's hello, but we are not telling the system how many characters we typed in. Right? So what the system does is fills up the characters at the beginning, right? Because we are on row 0. But look what happens. We are overflowing into the second array element. And here we have ME and the terminating character. So when we continue on, and I say hello you, okay, now what happens? This is the second element in our array. Now we have hello, and we used to have ME and the terminating character, but now it's overwritten because we are in the second row. First element is where we started filling the second row, index value 1. And we started overwriting the ME with HELLO, and then we continued writing and storing until we got the terminating null character. So now we are not processing the third element, but we are overwriting it. So we are reaching into that third element. So when we continue on, and I say hello us, now you can see that the third element is overwritten. Whatever the second element was overreaching, right? And now the third element is writing into the fourth element that we not processed yet. And now we can just say hello. Okay. And now you can say the array has hello, hello, hello. So if we now print out what is the value, let's get rid of these. Let's just print out what is the value, the first element of B, right? Just the first element of B. Okay. And you can see the stack around variable B was corrupted. Why is that? Well, if you look at our array, we have no terminating character, right? So we don't know where to stop. So let's just run this again. Okay, so we say hello me, hello you, hello us, and now you can see why is that just hell. Because as you can see how elements are overwritten, but because I typed in a short enough word for the last word, you can now see that we do have the terminating null character, even though we are only pointing to element 0. Element 0 has no clue that it only has 5 characters in its row. So it keeps printing out because it has no concept of where to stop processing the characters until it sees the null terminating character. So before we did not have a null terminating character, and we basically crashed the application. Right now, the first element in array B has a null terminating character, but even though that null terminating character exists, we're really going through every single one of the rows within the array. Right? So if you look at it, right, so we have an array, and this array is a two-dimensional character array. So we think about that as this is the first row, the second row, and the third row. First column, second column, and the third column. Okay? But we only have terminating character right here. So if we would have, let's say, 1, 2, 3, 4, 5, 6, 7, 8, right? Even though we're referring to the first row does not know where to stop until it sees the terminating character. And that is the reason why we printed out all the contents from first index, index 1, index 2, index 3, and now we're terminating it at index 3, last element. Just kind of strange how that works, but the C strings you have to understand, you have to feel a lot more comfortable with C++ and this language and how computers work in order to use C string, which is not your main problem when you are using a string. Okay? So hopefully this helped, and we'll continue on with many more examples next time. Still talking about strings. So see you next time.